Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 9, Lesson 2 on the circumference and the area of a circle. Now, Unit 9 really is all about solids, right? Three-dimensional shapes. But one of the big differences between Math 8 solid work and 6 and 7 is that in Math 8 we're going to start to work with objects whose cross-sections are circular in nature. And because of that, what we want to make sure of is that we review two important ideas and formulas regarding circles. How we find the length around a circle, known as its circumference, and how we find the area inside of a circle, known as the area. So let's jump into those right away and do some review from some work that you saw in Math 7. All right. Now, circles will be important when we start to study things like cylinders and spheres. Let's review some fundamentals, okay? So basic circle ideas. Number one, the most important, what is a circle? A circle is a curve made up of points that are an equal distance from a center point, all right? So every point on the circle is the same distance from the center as every other point on the circle. All right, that's concept number one. Now, concept number two is the radius. A radius of a circle is a segment that's drawn from the center to any point on the circle. Its length is typically given by the variable r for radius. No great surprise there. And finally, a diameter of a circle is a segment drawn from one point to another point on the circle that passes through the center of the circle. Its length is typically referred to by the variable d. Again, not a surprise. Now, side note, a little bit of a difference. Almost always, the radius of a circle is given by a lowercase r. But depending on what teacher you have, what state you live in, things like that, the diameter is sometimes designated by a small case d, sometimes by a capital D. Either way, thankfully, they use d for diameter and r for radius. All right, so let's get into an exercise where we make sure that we understand these ideas. All right, exercise number one. A circle is drawn below with a center at C. Points A, B, and D have all been marked on the circle with points A, B, and C collinear. Segment CA is 4 inches long. Letter A asks us to name all radii drawn in this circle. All right, go for it. Remember, radii are segments, so make sure to name the radii the way that you would name a segment. Pause the video now. All right, well, we actually have 3 radii that are drawn in this circle. Keep in mind that there's an infinite number of actual radii, but we've got the radius that goes from C to A, or A to C, it really doesn't matter, C to D or D to C, and then C to B or B to C. So, the radii in this case are CA with a little segment bar above it, CB with a little segment bar above it, and CD with a little segment bar above it. Those are all of my radii. Now, letter B. Name the single diameter drawn on this circle. Well, a diameter, keep in mind, is a line segment that goes from one point on the circle to another point on the circle and passes through its center. There is only one diameter that's been drawn on this circle. Pause the video now and name it for letter B. All right, well, we've got a line segment that goes from B to A, or from A to B, and passes through the center point C. So the diameter is either AB or BA. It just depends on which way you want to say it. Now, side note, it's really important that we knew that A, B, and C were collinear. If we didn't know that A, B, and C all lied in a straight line, then we couldn't really say that this was a diameter. Just like we couldn't say that BD is a diameter, because B, C, and D are not collinear, so there is no line segment, at least drawn, that goes directly from B to D. Anyway, it's pretty obvious that AB or BA is a diameter, so let's stick with that. Now let's take a look at letter C. What is the length of the diameter? Well, this should be pretty easy, but why don't you go ahead and write down the length of diameter AB. All right, well, it's again pretty simple, We know that BA or AB consists of AC and CB. Because both CA and CB are radii, CB must also be 4 inches, and that means that the length of AB must be 8 inches. And in fact, right, one important relationship between the diameter of a circle and the radius of a circle, or better yet, I should say the length of the diameter and the length of the radius, is that the length of the diameter is always twice the length of the radius, and equivalently, the length of the radius is always 1/2 of the length of the diameter. And that's really critical because some formulas involve the diameter and some formulas involve the radius. Sometimes you know one and not the other, vice versa. Just keep those relationships in mind. All right, now let's start talking about some other things that are important about circles. All right, so the circumference, which is the distance around the circle, and the area of a circle are important quantities that must be calculated using formulas. All right, they have to. So the area and the circumference formulas of a circle, which you learned in Math 7, okay, for a circle who has a radius of length r and a diameter with a length d, the circumference is given by either one of two formulas. Either the circumference is just pi times the diameter, awesome, right? Where pi is 3.1415, etc., right? We kind of reviewed a little bit about the number pi a few units ago when we were looking at irrational numbers, all right? But pi is a number that's just slightly bigger than 3, okay? Or the circumference is given by 2 times pi times the radius. All right, and again, that 2 just comes from the fact that 2 times the radius is equal to the diameter, okay? And which one of these you use is really kind of up to you and kind of up to whether or not the problem gives you the diameter or the radius. Now, the area formula of a circle is almost exclusively given in terms of the radius. The area is just pi, right, 3.1415, etc., pi times the square of the radius times the radius. All right, so let's get a little bit of work with these two formulas. Exercise number 2. A circle has a radius that is 6 inches in length. Determine its circumference and area to the nearest tenth. Show your formula substitutions and use appropriate units. All right, great. So I'm just going to do a little sketch of this circle here. All right, and I can show what my radius is by kind of drawing a point at the center of the circle, and then a line segment out, and then I'll label it as 6 inches. All right? We want to use these two formulas to calculate the circumference and the area. So let's do that together, and then we'll have you do some of them on your own later on in the lesson. Now, the circumference, right, probably the easiest formula to use, obviously, is pi times the diameter. All right? And there's nothing wrong with using that instead of 2 pi times the radius, because we can easily say the diameter, right, is 2 times the radius, and that's got to be 12 inches. So the circumference must be pi times 12, and we're going to let our calculator do that for us. All right? So let me just clear this out. I can just do 12 times pi, or pi times 12, it doesn't matter. And we'll get 37 point ugliness. All right, what do I want? To the nearest tenth, so 37.7. Now the circumference is a length, so its units have to be length units, 37.7 inches, not square inches or cubic inches or anything like that. Literally, if I walked around this circle, I would have to walk 37.7 inches in length. Now let's do the area. Now for the area, right, its formula is pi times the radius squared. So that's going to be pi times 6 squared. Now we could just put that in our calculator directly like that, or we could evaluate 6 squared, which would be 36, and then we could put in 36 times pi. So we could either literally do it like that, and we would then get an area of, if I enter, 113.1 square inches, or you could just put it in as pi times 6 squared, right? Which is going to give us exactly the same answer. It's really up to you in terms of whether or not you want to evaluate the 6 squared and then put in 36 times pi, or whether you just want to put in pi times 6 to the second. Your calculator will take care of it either way, and then we can round the answer to whatever we need to. Now, these two formulas are both going to be absolutely critical as we move forward in this unit. So we want to get more practice with them in this particular problem set. So let's do it. All right, let's take a look. Exercise number 3. An object is created consisting of 2 straight perpendicular sides of the same length and a quarter circle connecting them as shown. Letter A. Find the area enclosed by this figure to the nearest tenth of a square centimeter. Show your calculations. All right, so we need to be able to deal with quarter circles, half circles, also known as semicircles, all right? Or really any kind of portion of a circle that's kind of easy to deal with, a quarter, a third, a half, a fifth, whatever. Now, to calculate the area of the circle, hopefully it would make sense to calculate the area of the whole circle and then divide by 4 or multiply by 1/4. Either way, pause the video now and see if you can figure out how to find the area of this quarter circle. All right, well, we know that the area of a circle, right, is pi times r squared. But the area of this particular sector is going to be only 1/4 of that. So I'm going to build that 1/4 in right away. All right, my radius here is 5. And in fact, I'm going to put it all into my calculator just like that. Literally, I'm going to do 1 divided by 4 for the fraction 1/4 times pi times 5 squared. All right, and that is going to give me 19 to the nearest tenth of a square centimeter, 19.6 square centimeters. Now, there's also absolutely nothing wrong with saying, okay, let me first figure out the area of the whole circle, right? I might do that by just doing pi times 5 squared, right? So that would be the area of the whole circle, roughly 78.5, right? Then I could take that and just on my calculator immediately do divided by 4 and get my 19.6. That was my final answer, all right? I like to build it in all from the beginning. I know that I've got only a quarter of a circle, so I'm going to multiply the area formula of the whole circle, right? That's the area of the full circle with a radius of r, and then I'm going to multiply it by 1/4 because that's the portion of the circle that I have. Now let's take a look at one that's maybe a little more challenging. Letter B. Elliot has a piece of wire that's 20 centimeters in length. She wants to create this figure by using the wire to enclose the area. Does she have enough? Justify. All right, so literally Elliot is going to take wire, 20 centimeters of length, put a piece here, a piece here, and a piece here. The question is, will that 20 centimeters be enough? See if you can figure that out by pausing the video now and playing around with this problem. Well, right, in order to do that, she needs 10 centimeters at least just for here. Just for here, she needs 10 centimeters. But then she needs 1/4 of the circumference of a circle here. So what she's going to need, right, the wire, let's see if we can write it all out, right? She's going to need that 5 centimeters plus another 5 centimeters plus 1/4 of the circumference. Let me write it like that at first, okay? And then we'll deal with what the circumference is in a second, right? So we've got the 5 centimeters plus 5 centimeters plus 1/4 of the entire circumference, okay? So maybe I'll add the 5 and the 5 and get 10. Now, how do I find the circumference? Well, the circumference is pi times the diameter, right? Now, the diameter here is 10 centimeters. So I've got my 10 centimeters just from 5 plus 5, plus 1/4 times the circumference, which is pi times the diameter. Now, we'll let our calculator do the rest of this work. 10 plus 1/4 times pi times 10. Since the numbers are so messy here, it really helps it really helps to be able to put it all at once into the calculator. So rounded to the nearest tenth, Elliot's going to need 17.9 centimeters of wire. So let's answer the question, yes, she will have enough. Yes, she will have enough, right? Because 17.9 is less than 20. Okay. Now again, we should feel comfortable with dealing with quarter circles, half circles. Again, they're known as semicircles. As much as we can. Whoop. There we go. I don't know how we just popped out there. Let's take a look at one final problem. Exercise number 4. Figure number 1 below is created by removing 2 semicircles from a rectangle as shown. Figure 2 is created by joining 4 semicircles to a square. Which figure has a greater amount of area shaded? Justify your answer. All right, so this is a really nice problem because it involves both subtracting areas and adding areas. Hopefully you recognize that this particular figure, to calculate its shaded area, you'll have to do some subtracting of areas. Here, we'll have to do some adding of areas. So what I'd like you to do now is pause the video and see if you can figure out which one of these two figures has a greater amount of area shaded. All right, well, this is going to take a little bit of work. I want to give myself as much of the screen as I can. We'll bring the calculator back when we need it. But let's start with figure number 1. Now, with figure number 1, let's talk about some strategy, right? I'm going to calculate first the area of this entire rectangle, all right? And that's easy enough to do. Let me just bring this up. So figure number 1. Right, let's just be systematic about this, all right? We've got the area of the rectangle, and that's going to be 12 inches times 30 inches, which is going to be 360 square inches. Now, from that 360 square inches, I've removed, right, a half circle here, and I've removed a half circle here. But what that really means is that I've removed an entire circle. Right? I don't have to do a half circle, come up with its area, a half circle, come up with its area, and then multiply by 2. I can simply take my 360 square inches, right, which would be the area inside of the entire rectangle, and subtract off the area of this particular circle that got removed. So I'm going to say my area shaded is equal to that 360 square inches minus pi r squared, right? That's my area of the circle. Now, what is r? Well, in this case, r is 6 inches, right? And again, let's back up and talk about this a little bit, right? It's very important for you to look at this circle, right? And imagine I just moved that other part of the circle over here. So I just kind of bopped it over there, right? This circle has a diameter that's 12 inches, which means its radius must be 6 inches. And now I can put this into my calculator and figure out my shaded area. So let's do that. Let's bring our calculator up here. Let's do 360 minus pi, maybe bring this up a little bit farther, pi times 6 squared. And we get a shaded area of 246, and we'll just round it to the nearest tenth, 0.9 square inches, 246.9 square inches. Okay, now let's talk strategy for figure number 2. Now figure number 2 is a little bit more complicated, right? It's got a square in the middle that's 10 inches by 10 inches, and then it's got 4 half circles, or 2 full circles. Can you kind of see that, right? If I took, maybe make the picture a little bit more in there, right? If I took this semicircle and this semicircle and I put them together, I'd have a whole circle. This semicircle and this semicircle together, I'd have a whole circle. So what I'm going to do now is I'm going to kind of lay it all out, right? What do we have? Well, we've got the area. So for figure 2, right, we've got the area of the square. So we can go, I'm going to go right for the shaded area immediately. The area of the square is going to be 10 squared, right? That's the square. Then I'm going to have 2 times pi r squared, right? Now the 2 comes from the fact that I really do have 2 full circles there. All right, let me just bring this up. Well, before I do that, keep in mind that the radius of each one of those half circles, if you will, is 5 inches. All right, so my shaded area now will be 100 plus 2 times pi times 5 squared. We'll let our calculator do that. 100 plus 2 pi times 5 squared gives me, oh, this is a close one, 257.1 square inches. Let me get this out of the way. Close call, right? We have 246.9 square inches for figure 1, 257.1 square inches for figure 2, so figure 2 has the greater shaded area. Not by a lot, and certainly not something that you could really tell by just sort of looking at the figures, right? And I did try to draw these figures more or less to scale, and yet it would be very difficult to spot sort of the difference between 246 and 257 square inches just by looking at the picture. In fact, I would say it's actually pretty much impossible. Okay. Anyhow, let's wrap this up. Right? The unit that we're in is really not about two-dimensional objects. It's not about circles or squares or rectangles or anything like that. It's about three-dimensional solids. And yet the circumference formula and the area formula for circles are going to become important things for us as we move forward. And we're going to see a lot of formulas, especially for volumes of cylinders and cones and spheres, that also have pi's in them, the number pi, and the radius of the overall figure. So it's good to have some review of these two formulas before we get into those more complicated figures. All right, and we are definitely going to see lots and lots of circle work as we move forward. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.